In number 1, we're finding an area, so we're just going to subtract curves and take the integral from one intersection point to the next. So first let's find the intersection. So we're going to set these two equal to one another. Here we have x squared minus 4x plus 4 equal x plus 4, or x squared minus 5x equals 0. So we have intersection points x equals 0, x equals 5. Now, if we were to graph these two, this is a parabola facing up, and this is a line, slope 1. So we're finding this region, x plus 4, x minus 2 squared, and we found that the x values are 0 to 5. If we weren't sure which curve is on top, then you can just substitute something in between 0 and 5. Like let's say you substitute in 1. So if you put 1 here, you get 5. If you put 1 here, you get 1 minus 2 squared, which is 1. So this is underneath this one. All right, let's do our integral. 0 to 5, x plus 4, subtract x minus 2 squared. And we'll just integrate. We have x squared over 2 plus 4x minus x minus 2 cubed over 3. And we're integrating from 0 to 5. All right, let's just substitute in. We substitute in 5. We have 25 over 2 plus 20 minus 5 minus 2 is 3. So here we have 3 cubed over 3. And then substitute in 0, 0, 0. And here substituting in 0, we have minus 2 cubed over 3. And I'm just going to leave it like that. In 2a, we want to find the volume of the solid of revolution formed by revolving the region described in the previous problem. First about the y-axis and then about the x. Okay, so about the y-axis here, let's just draw the graph again. Here we have the line x plus 4. The slope is 1, and here this is the point 0, this is 5. And we're looking at x minus 2 squared. All right, so that's here's 2. Okay, so this region first is being revolved again around the y-axis. So we're going to, if we revolve around the y-axis, and we picture one of these rectangles revolving around y, we see that we get a cylindrical shell. So we're going to use the method of cylindrical shells. That tells us the volume is equal to 2 pi x, and then here we have the height, which in this case is going to be this minus this, x minus 2 squared, sorry, x plus 4, subtract x minus 2 squared, dx. Remember, this formula is based on 2 pi RH. Here's our 2 pi, the radius is x, and this is the height. And we're integrating from 0 to 5. We should simplify this. Okay, so let's do that. Here we have x plus 4 minus x squared minus 4x plus 4. Okay, in these brackets we have x plus 4 minus x squared plus 4x minus 4, just opening parentheses. Okay, so what's that equal to? This is, let's see, we have a 4 and a minus 4 that cancel. And so we have, here we have 5x minus x squared. So in brackets we have 5x minus x squared multiplied through by that x, so that would be 5x squared minus x cubed. And finally we integrate, power rule, and we just substitute in 5 and then 0. When we substitute in 0 we get 0, so it's just going to be 5. And here we have 5 cubed, that's 125, over 3 minus, and here we have 5 to the 4th, that's 5 to the 4th, 625 over 4. And I'm going to leave it like that. Okay, now we're revolving the same region about the x-axis. So if we look at one rectangle, revolve about the x-axis, and we get a washer. All right, let's remember the formula for the volume. So the volume is equal to, it's based on pi r squared, equal to the integral from a to b, pi. And for a washer, we have the large R squared minus the small r squared. So in our case, we have the integral from 0 to 5. The large radius squared, that would be x plus 4 squared, minus the small one, that would be this one. So we'd have x minus 2 squared, so that's to the 4th. All right, let's integrate this. And we have x plus 4 cubed over 3 minus x minus 2, 5 over 5. And we're integrating, and we're substituting in and evaluating between 0 and 5. So first substitute in 5. So we have 9 cubed over 3. And 5 minus 2, that's 3 to the 5th over 5. And now substituting in 0, we have 4 cubed over 3 minus 2 to the 5th over 5. Here we want to find where this function is increasing, decreasing, max, min. So let's look at the derivative. We have a product rule here. First times derivative of the second, derivative of the first times the second. And we'll factor out e to the 2x. Set this equal to 0. This is never 0. So if we do our plus minus analysis, we put the 0 of 2x plus 1 on the number line, and that would be negative a half. And this function is positive to the right, negative to the left. Negative means decreasing, positive increasing, so we have min at minus 1/2. And the y value just substitute into the original function, and we have minus 1/2 e to the x is minus 1/2, and this is 2, so we have a negative 1 here. So that's a min. And now we want to find concave up and down, so we're looking at f double prime. Let's look at the factored form. Alright, do a product rule of the first times the derivative of the second. Derivative of, this is 2, plus derivative of the first times the second. Okay, so we have 2e to the 2x plus 4x e to the 2x plus 2e to the 2x. And we're going to, again, factor out e to the 2x. Actually, here we have a 4e to the 2x. Let's combine these. We have 4x e to the 2x plus 4e to the 2x. So we're going to factor out e to the 2x times 4. And we're left with x plus 1. Okay, plus minus analysis. Put the minus 1 on the number line. And remember, this is always positive, so we're just all looking at x plus 1, which is positive to the right and negative to the left. So here it's concave down, and here our function is concave up, and this is an inflection point. So we have an inflection at minus 1, and substitute back in the original function. Is the original. And that's it.